Hello everyone. Today let's solve the problem number 199, binary tree right side view. Right. So you can just go through the question and you can try to understand the question with the help of example. So what the question states here, I'll just summarize the question so that it will be easier to understand. We are given the root of the binary tree. See, so you can clearly see here, we are given the root of the binary tree and we need to return the values of the nodes visible when viewed from right side. So this is important. We need to return the values of the nodes that is visible when viewed from the right side. The result should be ordered from top to bottom. So what is the keynote here? We need to return the values of the nodes visible when viewed only from the right side. This is the keynote here. So the result should be ordered from top to bottom. So top to bottom, the result should be ordered from top to bottom. That's what they have mentioned here, right? So let's consider this example here in this case. So let's let's make use of the level order traversal. Let's do this one level by level. This is level 1. So this will be level 2. This will be level 2 and this one will be level 3, right? So for first this one, we will be seeing the right node, right? So here this is 1, 3. The right node is 3. So we are getting 1, 3 here. So next let's move to this level. For 2 this is 5 and for 3 this is 4, right? So for 3 right side is right node is 4, right subtree or right node is 4. So 4 is there and 5 for 2 it is 5. So we have 1, 3, 4, 5 as output. So let's move on with the next this thing. What do you call next example here? So here you can clearly see 1 we have, for 1 we have 3. So 1, 3. For 2 we don't have any right side. For 4 we don't have any right subtree. For 5 we don't have any right subtree. So the output will be 1, 3. I hope this is clear. Let's move on with the next example here. This one doesn't consist of any element at all here. Empty tree or empty tree. Here the output will be empty array. So I hope this is completely clear. Let's discuss the approach first, followed by edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. Initially, let's go with the approach. So what will be the approach here? So we'll be making use of the BFS, breadth first search, level order traversal. BFS, nothing but level order traversal, to traverse the tree level by level. At each level, we store the last node's value in the result. This is very important. At each level, we will be storing the last node's value in the result. So we'll be going level by level. At each level, we will be storing the last node. So in this case, 1 will store 1. We only have one element at this level, right? For second level, we have 2 and 3. So 3 is the last node. We'll be saving 3. So for 2, we have 5. We will be, so null and 5 we have to consider here. Null and 5. 5 is the last element. We'll be saving 5 here. This will be 1 followed by 3 followed by 5. And finally, for 3, we have null and 4. Nothing but the last element is 4 in this case, right? So the total, this one we got here as final result is 1, 3, 5 and 4. Again, I have written 3 here. This is fine. 1, 3, 5 and 4, right? So that's what the output should be. 1, 3, 4, 5 or 1, 3, 5, 4, right? So I hope this is clear. So this is the approach that we'll be going with. What we'll do here, we will make use of the queue to store nodes in the level order. First of all, we'll be going with the BFS, this one, level order traversal. We'll be making use of queue here, right? So we'll be making use of queue to store the nodes in the level order. This we have to keep in mind. For each level, we are traversing all the nodes from left to right. We are traversing all the nodes from left to right. First we'll consider 2 and then 3. We are traversing from left to right. Store the last node of the each level in the result array. So we have discussed this one. We'll be storing the last node of each level in the result array. Finally, we will return the final result after traversing all the nodes. So this is the approach that we are going with. So now let's discuss the edge cases one by one. I hope the approach is completely clear. BFS level order traversal, and we'll just store the last level, last node at each level. So this is what we have to keep in mind. So next step is let's discuss the edge cases one by one and then finally write the code, right? So now let's discuss the edge cases one by one. So let's go with the first edge case, nothing but the empty tree here. So let me consider here empty tree. This is for the condition empty tree. Input, let me consider empty tree. Here this does not involve any elements inside the array, right? So here no nodes are present, so nothing is visible here. So the output will be empty array. So this is for the empty tree. Next, let's move on with the second edge case, nothing but only left nodes. So only, let me consider here, only left nodes. So let me consider here input 1, 2, null and 3 here. I hope this is clear. So here only left children exist. So the last node at each level is part of the right side view here, right? So this one will be 1, 2, null. This one I don't have to consider null. This one 1, 2. This one will be basically 3 here. So just give me a second here. Here we have 1, 2 and 3 as output, right? So we had for this one we have the input 1, 2, null and 3. So the output will be here in this case 1, 2 and 3. Why the output is 1, 2, 3 here? Only left children exist here. So the last node at each level is part of the right side view itself. So the output will be 1, 2, 3 in this case. Let's move on with the third edge case. Nothing but only right nodes here. So in this case, this will be 1 null, 2 null 3, right? So this will be in this one I did a mistake. I think this one left we have to consider, right? Only left one. Let me delete this one. This one has to be 1, 2, 3 only left. So we are considering the last element at every level, right? So that's what the approach says. So this one, the last element is 2, last element is 3. So the output will be 1, 2, 3 here in this case. Only left nodes we are considering. So for this one, we are considering only right nodes. The input will be here 1, 2, 1, null, 2, null, 3, right? This will be the input. The output will be here 1, 2, 3. So since each node has only a right child, so here each node has only a right child. All the nodes are visible from the right side. Nothing but here 1, 2, 3 will be the output in this case. This is for the condition only right nodes. This is fine. Finally, let's move on with the fourth edge case. Nothing but full binary tree. While I say full binary tree, let me go with 1, 2, 3, 4, 5, 6, 7. Right? I hope this is clear. This is the output will be here. So this will be full binary tree 1, 2, 3, 4, 5, and here 6 and 7. This one will be 1, as we have only one element, root node. Yeah, this one we are considering the last element. This will be 3. For this one we'll be considering 5. This one will be considering 7. So output will be here 1, 3, 5 and 7. Right? So I hope this one is completely clear. So just give me a second here. Did I miss something? So this is just for the condition full binary tree here. This is fine. Let's move on with the final edge case. Nothing but tree with missing children. So I'll just give here tree with missing children. So here let me give one thing here. Input will be 1, 2, 3, null, 5, null, 4. This is fine. So here we are just seeing the last node at each level, right? So last node at each level will be here 1, 2, 3. This one will be null, mm, null and 5, right? So this is 5, null and 4. So the output will be here 1, 3, 5 and 4. So here this is for the condition tree with missing children. I hope this is clear. We are just seeing the last node at each level, right? First we'll consider this one. So it will be 1. At this level we are seeing this one as we are traversing from this one. For this one, we are seeing right side. We are considering only 1. At this level we are seeing only the last this one element. We are traversing from left to right. At this one we have only one node. So at this level, we'll be considering this level, this one, and finally this one, right? So I hope all the 5 edge cases are clear. Then let's move on with the this one. Let's write the code, and I'll explain the code while writing the code itself. And then finally, let's discuss the complexities of the code that we have written. Let's start writing the code. First, this one, if tree is empty, then we have to return empty array. How can we articulate that one in the form of code? I'll just write a simple if condition. If not of root, then we'll just return empty array. This is fine. Next step is let's initialize a resulting array as well as queue, right? So basically array to store the final right side view, nothing but the last element at each level, and another one is queue for level order traversal, right? So I'll just come here. Let me initialize result to the empty array, and queue we are considering. I'll just consider the letter q itself in short form. So let me pass the root. So next step is let's perform the BFS traversal until the queue is empty. So we have to have some element within the queue to proceed, right? So while of queue dot length. So initially I'll just give here let size equals queue dot length. So this is nothing but number of nodes at the current level. So next let's move to the next part. We have to process all the nodes at current level and remove the front node from the queue. So for this I'll just make use of the for loop here. For let I equal 0, a less than size. Let's increment this one. So after doing this, after processing all the nodes at current level, we have to remove the front node from the queue. So to remove the front node, I'll just make use of the shift here. Dot shift. So I hope this is clear. The next step is we have to store last node's value in the result at each level, right? How can we write that? I'll just make use of if condition. If I equals size minus 1, then we are just storing the last node result dot push as value of the node, nothing but node dot val here. So this is fine. I hope everything is clear till here. Next step is we have to add the left child and the right child if it exists, right? So this is simple if condition. I can just this one we can articulate in this way in the form of code. I'll just give here if node dot left, if the node left node child if exists. So I can just give here q dot push of node dot left. This is fine. Let me paste this one here. Node dot left. This one I'll just give node dot right. Q dot push of node dot right here. I hope this is clear. So next step is after this step we have to return the final right side view. This one I'll just give return result. So let me format the code once. Let me hit the node is not defined here. Node dot left and node dot right. So just give me a second here. So what I have done in the line number 10, you can clearly see here, I have just given let equals q.shift. So here I have to initialize node to q.shift. So this is fine. Let me format this one once more and let me hit the this one, run button. So here you can clearly see all the sample test cases are getting passed. So let me hit the submit button now. So now you can clearly see all the test cases are getting passed. So the code works absolutely correct. So let's quickly discuss the time complexity and the space complexity of the code that we have written. So the approach that we went with here is BFS, or the level order traversal. So we know that. And what would be the time complexity here? So overall time complexity in this case would be big O of n, right? Each node is processed only once, or each node is processed once, right? At every level, each node is processed once. We know this. So overall time complexity here would be big O of n. And what would be the space complexity here? The space complexity would be big O of n as well. Why? Because in the previous problem we solved also, I have said the same thing. Q can store up to n nodes in the worst case. We know this. Q can store up to n nodes in worst case. So the space complexity would be here big O of n. We are making use of BFS level order traversal. Nothing but BFS with Q, right? So overall time complexity and the space complexity would be big O of n here. I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.